Chapter 2, Basic Chemistry. In this chapter, we are going to talk about basic chemistry. So first of all, what is chemistry? Chemistry is a branch of science that studies the nature of matter, how its building blocks are put together, and how they interact. And what is matter? As we all know, matter is anything that occupies space and has mass. Matter exists in 3 different states, which are solid, liquid, and gas. There are 2 types of change in matter: physical change and chemical change. As the name suggests, a physical change affects a substance's physical properties, like the melting of ice cubes, and the chemical change affects its chemical properties, like the rusting of iron. Let's proceed to energy. Energy is the opposite of matter since it has no mass and no space. When energy is at work, we refer it as kinetic energy, and potential energy when the energy is inactive and stored. We have 4 forms of energy that are important in body function: the chemical energy, electrical energy, mechanical energy, and radiant energy. Now let's move on to the composition of matter. So an element is a unique substance that cannot be decomposed into simpler substances by ordinary chemical methods. A complete listing of the 118 elements that have been identified appears in the periodic table. Moving on, the building blocks of elements are atoms, which has 3 subatomic particles: the protons, the positively charged, electrons, negatively charged, and neutrons, which are the neutrals. The planetary model of the atom portrays all the mass of the atom, the protons and neutrons, concentrated in a central nucleus. The orbital model also locates protons and neutrons in a central nucleus, but it depicts electrons as occupying areas of space called orbitals and forming an electron cloud of negative charge around the nucleus. Each element is a given number called its atomic number, that is equal to the number of protons its atoms contain, while the atomic mass number is equal to the sum of the protons and neutrons in the atom's nucleus. The atomic weight is approximately equal to the mass number of the most abundant isotope of any element. Isotopes are different atomic forms of the same element. They differ only in the number of neutrons. Now let's discuss molecules. Molecules are formed when 2 or more atoms are combined chemically. It is either atoms of the same element is combined resulting to a molecule of that element, or atoms of different elements combined referred as compound. Moving on to chemical bonds and chemical reactions. Chemical bond is an energy relationship that involves interactions between the electrons of the reacting atoms. Chemical reactions, on the other hand, occur whenever atoms combine with or dissociate from other atoms. Electron shells or energy levels are the orbits around the nucleus, and its outermost shell is called valence electrons. Valence electrons is important in chemical bonding. There are 3 primary types of chemical bonds, and these are ionic bonds that form when electrons are completely transferred from one atom to another. Second is covalent bonds, involved in the sharing of electron pairs between atoms. And lastly is hydrogen bonds, are fragile bonds that bind together water molecules or different parts of the same molecule, but do not involve electrons. Most chemical reactions have one of the 3 recognizable patterns. Synthesis reactions occur when larger, more complex molecules are formed, which can be simply represented as A plus B equals AB. Decomposition reactions occur when a molecule is broken down into smaller molecules, atoms, or ions, and can be indicated by AB equals A plus B. Lastly is the exchange reactions. Exchange reactions involve both the making and breaking of bonds. It can be generally indicated as AB plus C is equal to AC plus B, and AB plus CD is equal to AD plus CB. Now it's time to know about biochemistry. Inorganic compounds making up living matter do not contain carbon. Exceptions include carbon dioxide and carbon monoxide. They include water, salts, and some acids and bases. Water is the single most abundant compound in the body and acts as a universal solvent. Salts, in ionic form, or the electrolytes, are involved in nerve transmission, muscle contraction, blood clotting, metabolism, and many other reactions. Acids are proton donors. When dissolved in water, they release hydrogen ions, while bases are known to be proton receptors. When bases and acids interact, neutralization occurs. That is, a salt and water are formed. The relative concentrations of hydrogen and hydroxide ions in various body fluids are measured using a pH scale. A pH of 7 is neutral, a pH below 7 is acidic, and a pH above 7 is alkaline. Normal blood pH ranges from 7.35 to 7.45. So now let's talk about organic compounds. Organic compounds are the carbon-containing compounds that comprise living matter. Many organic compounds are polymers. Polymers are chain-like molecules made of many similar or repeating units, which are joined together by dehydration synthesis. Dehydration synthesis is when monomers are joined by removal of hydroxide from one monomer and removal of hydrogen from the other at the site of bond formation. On the other hand, the reverse process is hydrolysis, when monomers are released by the addition of a water molecule, adding hydroxide to one monomer and hydrogen to the other. Carbohydrates contain carbon, hydrogen, and oxygen in the general relationship of two hydrogen atoms to one oxygen atom and one carbon atom. Monosaccharide means one sugar or simple sugars, while disaccharides are double sugars, and polysaccharides are branching chains of linked simple sugars. Whereas lipids are a large and diverse group of organic compounds. They enter the body in the form of meat, egg yolks, dairy products, and oil. Lipids include triglycerides, phospholipids, and steroids. So first, this is the formation of a triglyceride. Fatty acid chains are bound to glycerol by dehydration synthesis. Next is the typical structure of a phospholipid molecule, phosphatidylcholine. Two fatty acid chains and a phosphorus-containing group are attached to a glycerol backbone. Lastly, cholesterol. Simplified structure of cholesterol, a steroid formed by 4 interlocking carbon rings. Let's proceed to proteins. Proteins account for over 50% of the organic matter in the body, and its building block are amino acids. Proteins can be described in terms of 4 structural levels. Proteins are classed as either fibrous proteins or structural proteins that are strand-like that appear most often in body structures, or globular proteins or functional proteins are mobile, generally compact, spherical molecules that have at least tertiary structure. Examples of functional proteins are enzymes. It regulates essentially every chemical reaction that goes on within the body. Moving on, nucleic acids make up your genes, which provide the basic blueprint of life. The building block of nucleic acids is nucleotides. It consists of 3 basic parts: a nitrogen-containing base, a pentyl sugar, and a phosphate group. The two major kinds of nucleic acids are deoxyribonucleic acid. It is a genetic material found within the cell nucleus. And ribonucleic acid. It functions outside the nucleus and can be considered the molecular assistant of DNA. Before we end this video, let me tell you first the most important ingredient in cellular work, and that is adenosine triphosphate or ATP. It is all important because it provides a form of chemical energy that all body cells can use. That's all for today. See you in the next video.